Good morning, good afternoon, good evening. Assalamu alaikum wa rahmatullah. It depends on from where you are joining the program. Welcome back to the Ramadan program, the 10-week program. And today we are going to start week number 6, actually week number 7. And this is most exciting part of the program, and that is understanding the machine learning, how machine learning works. So that is what we are going to cover today. So we are going to talk about machine learning in general as a concept, and of course we'll start talking about some models. No, we are not going to cover all models possible, so we'll try to cover at least 2 or 3 models in this program. So that is the plan. So far, this is all what we did. We have completed the data pre-processing. So we got a nice data set. It's all numeric. Of course, we got some large values, small and small values, large values and small values. So one last step that we had to do, or we have to apply, and that is before feeding this data into machine learning, is scaling this data to avoid any biasing that we might not know of. So that is the plan. So talking about machine learning, and so let's first of all get through what we covered so far. So we started the program with understanding the problem. So we learned how to frame a business problem, how to transform a business statement into an analytical business problem. Then we moved into data understanding. This is where we learned how to read data into a system, in our case, into Jupyter Notebook. We learned how to manipulate data, explore your data using ADA, apply some data visualization and statistical analysis. Then we learned how to design a code book and quality book. Then we moved into data preparation, where we learned basic things about how to fix a target variable, how to look into data auditing, quality auditing, look into duplicates, redundant, how to handle missing values, options available. We learned some options about how to handle outliers, how to look into categorical data and check its cardinality, how to transform categorical data nominal versus ordinal. Then we learned about some transformation method, log method, to fix the skewness. Then we talked in brief about some other transformation methods like normalization, factorization, binarization, standardization. Then we talked about correlation analysis as a method to help us do some feature selections. So we learned how to aggregate and do some binning, apply correlation analysis. And at the end, we learned how to extract or how to design a ready-to-go in a version of the raw version data that we started with. So it's a journey. So we started with the raw data, where the data has a lot of quality problems. And of course, we prepared the data, and now we got a version number 2 or version number 3. And this is the latest, the most ready to go version of the data that we have. Okay, so everything is ready to go. Okay, so now it's ready for the modeling. It's ready to do some modeling, but before we feed the data into the modeling, let's first understand machine learning. What is machine learning? How these models are taking the data and approximating the reality. So that is what we need to learn. But in theory, we need to select a model. Then we need to split the data, at least for two partitions. We need to scale the data, especially if we are using non-algebraic models. Then we need to have something handy, something to compare the model with. So that is called random guess. So if I were to guess if a client will purchase a premium, it should be probably 50-50, and we want to build a model that beats our dummy model, our guessing. Then we are going to learn how to build an actual model, how to train the model in one partition. So we are going to partition the model into 20%, 80%, I mean 20%, 80%, or 70-30, 75-25. We are going to have two partitions. One has to be larger than the other. And the larger part will be used to train, to learn. And the smallest part or partition will be used to test. And after that, we are going to compare. And of course, we are going to we are going to build many models. Depends on the analytical approach that we already determined at the beginning. So we are going to build many models using different sampling, different partitioning, different data sets, etc. And at the end, we are going to need only one model. It's only one model that we are going to need, and this one model, of course, this is one model that meets the criterion. It could be accuracy, it could be the speed, it could be anything. And even this one model, we are going to try to improve it by optimizing its parameters and tune its parameters. And at the end, we are going to get one model, one best model with optimal parameters. And finally, we are going to deploy that one model into production for, of course, for a value, return of investment in our case. So now we are going to do machine learning. So machine learning in general is simply a child. Is simply a child that is small child, 3 months, 4 months, and as you already know, children at this early age, they have the ability. It's a built-in ability to learn the environment. They do anything, they touch everything, they put everything in their mouth, grab, they really don't care. They don't know if an object is deadly, if an object is going to hurt them. They really don't care. So they out of the curiosity, they challenge themselves to learn the environment. That is a machine learning. Machine learning is simply a child walking on the highway, and this child saw a candle, and saw a candle, and out of the curiosity, this child, of course, wants to discover what is this object. So the child put a finger on the flame. A child put the finger on the flame, and he got burned. He got hurt, and the child could learn two things from this incident. The child could learn two things from this incident. Either the child is learning the object, so he remembered the shape of the candle, the color of the candle, the size of the candle, the position of the candle. He learned the object in general. Or the child learned a pattern about the object. So whatever the child learned from this incident would determine the following experience, would determine the next experience. So, and the same child next day was walking on a kitchen. Again, out of curiosity, the kids, they are experiencing any surrounding environment. So the same child saw in the kitchen a stovetop, and again, it's our curiosity. The child wants to put the finger on the top stop. So if the child remembered the object from yesterday incident, that is a candle. Of course, the candle does not look like the stove top. Of course, the child is going to repeat the same incident by putting the finger on the stove top, and of course, he is going to get the same experience. That is going to hurt himself. But if the child remembered the patterns from yesterday incident, that is anything that is bright, red and bright, is a hurt, is a deadly. Of course, the child will not come closer to the stove top. So I repeat, if the child remembered the object itself, he's going to repeat the incident. He's going to repeat the experience. If the child remembered, if the child learned the patterns from yesterday incident, of course this incident, if has the same patterns, then of course the child will stay away. So the pattern that we learned yesterday is anything that is red and bright is deadly. And so this one is bright red. Of course, the child is not going to come closer. That is machine learning in general. That is machine learning. So machine learning is simply takes the data, and you got two options again. Either machine learning remembers every bit of the data that you are feeding into it, or the machine learning remembers the pattern or the signals or the relationship or the correlation that governs that data you are feeding into it. Either way, if the machine learning remembers the data, if you feed any new data into it, it is not going to do any good, because the new data, if the new data looks like the data that the machine learning remembered, of course the machine learning is going to do a better job because it already have a knowledge about a certain type of data. But if new data that you are feeding into this machine learning is totally different than the data that we feed it at the early training, of course the machine learning is not going to do a good job. Otherwise, if the machine learning remembers a pattern, any pattern within your data, rather than remembering the data, memorizing the data, of course, we are going to apply that patterns on any known, unknown, unseen data. That is machine learning in a nutshell. Any question, concern? And this is a this is the difference between machine learning and programming. So in machine learning is give a child the freedom to experience the surrounding environment, let them learn the patterns and apply the patterns on any surrounding object they will encounter in their life. That's machine learning. Programming is totally different. The programming is simply telling your child, hey kid, don't come closer to the candle because you'll burn yourself. Stay away from a gun. Don't come closer to the medicine because you might kill yourself. Don't drink this water. It's poison. Don't do this, do that. Don't do this, do that. That is programming. You are programming your child to do specific things based on some conditions. Machine learning, let your child learn on their own. Your children learn on their own and learn patterns and apply what they learn in new objects, new incident, new environment. Questions, concerns about machine learning? Questions, concerns? If you are not talking, please mute yourself. Otherwise, I'm going to take care of the room. Abdullah, please mute yourself. Okay, any question, any concern, any doubt about machine learning? Everybody, please speak up. I want you to speak up. Don't chat. Please speak up. Is it clear?
So in general, define it as learning from the data itself and predicting the next time you have something similar, whether that knowledge of whatever you have learned is it the same thing or is it different thing, and then make a decision based on that learning, right?
Can you please repeat your question?
No, I'm just saying is that in general, when you say machine learning, it means that you've been presented with some data, some pointers about anything, and based on that pointers, you learn what that thing is, and the next time if you are presented with a similar thing, at least property-wise, you say, okay, is this thing or that thing?
So machine learning is getting the data. Of course, pre-processing that data and learn patterns. Sometimes machine learning does not learn patterns. Sometimes machine learning memorizes the data. If your machine learning only memorizes data, it is not going to do a good job if you were to apply it, that same machine learning on a different data set. If a machine learner did not memorize the data, it only learned patterns from the existing data. Of course, it is going to do, once you feed a new data set, if it's similar to the first data set, the machine learning will do a better job. So you want to build a machine learning that looks for patterns, not memorize your data.
Okay.
And here is the problem. Here is the problem. Think about it. So the child or machine learning remembers or the patterns, learn the patterns that anything that is red and bright is really, really a problem, really serious problem. What if next day is your child's birthday, and of course you brought a red toy to your child? What do you think the child is going to do? So this is bright and red, right? What do you think? And the child already learned that anything that is red and bright is no. What do you think the child is going to do with this?
He's going to
not touch it.
It's not going to touch it. That is exactly machine learning. So machine learning, they are not 100% right. So we need to keep. We need to give a child many a combination of many red and bright deadly objects and many red and bright nice toys and objects. That is how we train a child on series of patterns. So next day, when regardless if the object is deadly or good, the child will make a difference. The child will make a better decision. So again, machine learning is all about if the machine learning remembers the object, of course, it's not going to do a good job on the stove top. Of course, it's not going to do a good job on the top. If the child of machine learning remembers the object. So this is an object. So we know the shape, we got the flame, we got the color, the size, and everything. But if the machine learning remembers, remembers the patterns, of course, we can tweak that patterns to differentiate between the no's and the zeros and ones, and the yes and no's, and the bad and good, etc. So machine learning is not always right. So,
yeah. So Mo, I have a question.
yes, sir.
So you explained the data processing, like analyzing, understanding, figuring out outliers, removing zeros, redundant. So this machine learning thing comes post processing, after you are done with the post processing the data, or you basically you have the data from the industry or anywhere. And then you directly apply the machine learning on it. I'm kind of, if you can connect these dots, that would be good.
Sure. You cannot definitely apply. You cannot apply machine learning straight to a given data set. So remember the GIGO concept that we learned is garbage in, garbage out. So machine learning is the last step. So you have to prepare your data first. Then once you are ready, then now we got the machine learning to apply.
Okay, understood. Thank you.
And some of the machine learning, machine learning is not always used for production. There's a lot of machine learning that are used for pre-processing. So you could use machine learning to prepare your data.
Okay.
Like dimensionality reduction, PCA, kernel PCA, LDA, quadratic and linear discriminant. These are machine learning, and you can use them to pre-process, prepare, make your data ready. So machine learning is used for prediction and modeling, but it can be also used for preparing, pre-processing the data. But you cannot use machine learning on raw data. So if you use machine learning on raw data, you are going to get garbage out, garbage in, garbage out. And of course, that is not what we hired you for.
Okay, thank you.
Okay. So another example, this is a very, an analogy, and my sincere apologies if you feel like it's too low explanation, but I'm going to try to explain it to a lowest level so you can understand exactly the life cycle of analytical project. So let's assume that I am a lioness. I have a land. I have a big forest, big jungle that I've been running for the last 20 years or 5 years or even 5 months. Now, what I've been doing is we gotta pray. So this is me, and of course, I do one effort, I fail. I do a second effort, I fail. A third effort, I fail. A fourth effort, I fail. And finally, the fifth effort, I got a prey. So I got many to one. That is how I am doing the business as of now. So I put a lot of efforts during the day, and I finally get that 1 or 2 prays per day. And I hired you as data scientist. I want to change this. I want to change this to a better business model. And one of the better business model is, what would be a better business model? Is one to many. One to many means I'm going to put one effort and I'm going to catch as many preys as possible. Is this possible, transforming from the manual to a systematic, automatic method? Yes, it's possible using machine learning. So I hired you. I'm Lioness. You are the fox. You are my data scientist. In this example, you are the fox, and I hired you to help me transform the business from many efforts and one catch, one prey, to one effort and many prays. So next day you came in, and of course your job is before you start looking for a solution, you first need to understand the problem, understand the data. So you looked into the data warehouse, and you looked into the jungle, and of course you need to learn about it, its creatures, events happening in the environment, the size, the type of the creatures in it, the type of trees, the weather. So we got all the information possible about the jungle. So that is the first thing I gotta do here is try to understand the helicopter view of the problem, the big picture of the problem. The third step is now you needed some of the historical data. So you come to me and you ask about all the information, all the summary of my historical data. Means how many times, how many efforts we put during the day, how many praise that we got for the last 6 months, 8 months, 12 months, where in the jungle, what part, what time, is it during the morning, evening, is it during summer, what's the seasonality, and etc. So you need some historical data. And once you get the historical data, of course, you are going to do some descriptive analytics using, you are going to do some ADA, exploratory data analysis, trying to find some patterns within your data. So you could do data visualization, you could do statistical summary, statistical analysis, descriptive analytics, etc. It's simply trying to answer questions like how many effort we put during the day, how many hours during the day, during the night, and how many praise, where, when, etc. Simply trying to understand what happened during the last 6 months of the historical data. And once you got the information, now we are ready to put some machine learning. A machine learning that looks into this historical data and find patterns, find some signals, some relationship between all the effort and the target variable is the value of the prey, or the number of the prey that we caught every day or every week or every month. So we are going to build some machine learning to learn patterns, not to memorize the data. If machine learning memorizes the data, of course, it's not going to do a good job for tomorrow. So we want to find patterns. So, and once we get those patterns, of course, we are going to optimize them. Now, we are going to build a machine learning to find patterns. It's called predictive analytics. And in our case here, we got if the lioness goes north, stays there 20 minutes, then go down, then cross the river, then go north, is going to catch the prey. In other patterns, if the lioness wakes up early in the morning, cross the river, then turn up, is going to catch the prey. And we got so many patterns, but we are going to find the optimal one. So the optimal way is just wake up. Instead of wake up in the morning, we are going to wake up at noon, go straight for 10 minutes, then boom, got a prey. So we are going to optimize that simple patterns that we learned to maximize the output. And finally, instead of we are going to automate the model, we are going to automate the model by simply digging some trenches across the forest and put some automation in there. So now we are going to have one. So we started by one effort, many efforts, and one prey per day. Now we are going to have one trench being being built in a certain area of the forest, and we are expecting many prays per day. So this is your life as data scientist. You get hard as data scientist, understand the problem first, get the historical data, learn about the historical data, build the machine learning to approximate the historical data, optimize the machine learning, then finally deploy it and optimize it and deploy it and automate it. That is very simple. That is your life as data scientist. And as you might already been aware of, the largest part, or the part that requires a lot of effort, a lot of studies, a lot of research, and is the first part, or the first cycle, or the first what do you call it, steps of the process. Learning about the business problem, understanding the data, and that's it. Learning the problem, learning about the data. Okay, so
Mo, I have a question.
yes, sir.
Yeah, in the previous slide, what is the significance you have chosen Lioness and Fox? I mean, do they have any real meaning in the
No,
real
it's
business?
simply trying to use this analogy to explain the concept of machine learning, the concept of analytical life cycle. That's all why. So
Okay, what is Tensei Doug in the this machine learning world? I mean, where do they create a hole for the people to get into their business, and do they really do this in the real world to
yes,
create a?
yeah.
Okay.
Yes, in the real world, you are going to get hired. So you are going to get hired as a scientist. That is the first step. Okay, and of course, the business will share the problem with you. So your job is, before you start looking for a solution, you need to understand the big picture, right?
Mm-hmm.
And after that, you are going to ask them about the data, historical data. It could be 5 years, it could be 5 months. And once you get that data, we need to apply some descriptive analytics, data visualization, statistical analysis, etc. After that, you need to model it, approximate the reality. So this is modeling. And once you build a model, of course, you need to optimize it, you need to prune it, you need to improve it, and finally, you automate the solution to production.
Okay. Okay.
Okay, it's the same concept, but using the analogy of Lioness and the Fox probably would clear a lot of those in your head.
Okay, got it.
Okay, so when we have this, these 6 months, once we when we have a historical data in general, so once we once we audit its quality, we learned about its quality, we learned about we did everything we could in terms of fixing redundant duplicates, missing values, outliers, to make this data set a learning experience for our machine learning. Then we need to do one thing. So we need to split the data into two parts. Okay, that is very important. So this is our 6 months, let's say 6 months data. And let's say that we have 6 million records. Okay, so we one of the method This is only one. There are so many methods to learn, to train, and learn from this historical data. Learn what? Learn patterns. Learn patterns and relationship, not memorizing. We don't want to memorize this data. We want to learn patterns that governs all pieces of it. So one method is we are going to split this data into 80% and 20%. So you got 6 million here. This is our 6 million records. We are going to split randomly into 80% and 20%. So for the 80% is called training set. As a partition is the part of the data that we are going to train. We are going to fit and train. So we are going to apply a machine learning. Machine learning is only simply a mathematical function, mathematical equation. So we are going to apply some mathematical function on this training set. And of course, we are going to learn some approximation. We are going to learn some statistical model. We are going to learn a pattern or a signals or relationship. We are going to learn associations, mathematical associations. We are going to learn so many things. And whatever we learned, we don't know how good it is. We don't know how good this pattern is. It could be we simply learned that anything in red and bright is harmful. But how about if we were given, if the child was given a tie, a red tie. So we learned something out of this 80% using mathematical function, but we don't know how good, how accurate whatever we learned. So we are going to take this pattern that we learned on 80% and we are going to test it on the 20%. So we are going to test it on the 20%. 20% calls test data set. So once we test, then we are going to compare the accuracy, and if everything goes green, then now we are going to deploy it into production. So this is production. Okay, that is in a nutshell the way machine learning learns, the way we implement machine learning to our data. So we are going to get the data. We are going to randomly split it into two partitions. It could be 80 and 20. It could be 70 and 30%. It could be 75, 25. It doesn't matter, the partitions, but a rule of thumb, there's no rule of thumb, but culture is 80%, 20%. So we are going to split into 80%. Then we are going to apply a machine learning algorithm, which is simply a mathematical function to this numerical data. This is all numeric, tabular numeric, and we are going to apply some mathematics on it, and we are going to learn statistical model or a pattern, and of course we are going to test that patterns on the remaining partition, that is 20%, and if everything goes green, now it's ready to deploy it into production.
Mo, I have a question.
Yes, sir.
So, okay, the 20% of data that is going to be preserved to test our model on, do we expect like 100% of accuracy, or we expect like a number, like a 90% of accuracy? Because I'm not sure, like, I don't know how that does it work, because usually it might be like from, let's say the 20% is like, let's say 1,000 record. From that 1,000 record, you may get like 50 records that are not that failing and not check marked.
So the way it works, so number one, we know. Let's say that in our example here, So we are trying to determine if a client will purchase this product. That's what we're trying to determine, right?
Yes.
So if you were to guess, what would be the probability? Let's say that you are the bank, you are an analyst for this bank, and I just showed up, and I signed up for the service, and you were to guess on me.
From what I see, the result, I mean, the prediction will be 0.
No, we got zeros and we got ones.
Oh,
So
okay.
what is the probability that I'm going to be a 0? What is the P of 0 versus the P of 1? This is something that you already have. We already have them. So how do we find the probability of 0? Anyone? How do we get the probability of a 0 in this example? In this example, how do we determine a probability of a 0 and the probability of a 1?
We only have two options, 0 or 1, so it's going to be 50%.
No. Yes, we have a 0 or a 1, but we got some difference in there. How to find the probability of 0? And there's some ones in there. How do you find the probability? What is the probability number 1? Probability is a chance or likelihood is going to be a 0, and the 1 is a chance or likelihood to be a 1. So to find the probability of zeros, we are going to find how many zeros that we have divided by what?
The total of zeros and ones?
Thank you, sir. So it's going to be number of zeros divided by the total of zeros plus ones. In other words, divided by what?
The total of records?
Yes, total of records. And the probability of 1 is going to be a number of ones
Divided by total records.
divided by the total of records. So when Momidwani comes in, you already have this. Now in our so how many records that we have? 41,000, I believe 128. I don't remember. I think it's 41,000. 41,128. So I think we have 8,000 and you got 20,000 of zeros and the remaining of ones. So if you do the math, you have a flip coin. You have a guessing number. So we want to defeat this methodology, this process. If you were to guess if mo is going to be a 1, simply find how many ones that we have in the historical data, divide by the total records, and you are going to get a probability for mo being 1. If you want to determine if mo is going to be a 0, find how many zeros that we have in the historical data, how many people who did not purchase the term in the historical data, divide by the total value, then you are going to get a probability. Okay, so we want to beat this. Of course, if we were to use the guessing, I don't need you. No one is going to hire you. So we want to use a machine learning that looks into the patterns and determine the probability of zeros and ones from the patterns, not from remembering the data. Okay, Amin?
Okay, thank you.
You're welcome. Any other concerns, please?
Sorry, my brother. So the problem is here when you divide the data 20 and 80%, and you mentioned random sampling. Here is the problem: if all 80% got like a 0 and 1 goes to other one, how? This is actually question: how we divide this one?
Yeah, because we are going to try it. We are going to train the model many times. and every time it's going to pick a random set. So we are going to keep training until it learns a pattern. Yes, of course, let's say that 20%, let's say that 20% of your data is 0 and 80% of your data is 1. And since it's random, there is a possibility all ones will be in one side, or is going to be in one side. That is, there is a problem. There is that possibility. That's why we are going to train and keep training, run it multiple times until and of course we are going to compare. The result. So the accuracy will determine if the model is underfitting or overfitting.
So we are going to divide this by using machine learning or just manual divide?
No.
We took a kid here.
It's
Machine learning.
It's a method, using machine learning.
Mm-hmm.
It's
Okay.
using the codes.
Mm-hmm. Okay, thank you.
Yeah, welcome. So other concerns, questions about the machine learning, please. Okay, so hopefully that is clear. And so sometimes we split into 3 sets. Training set, which is going to be a training set, validations data, and test data. Sometimes, but in most cases, you will be splitting your data in 2. Okay, and here we go. So this is traditional programming. You are telling your child what to do. In the machine learning, you give your child the data and let your child learn the program. In the programming, you are giving your child a set of instructions, do and don't do, and let him learn patterns. For the machine learning, we got the data, we got the patterns in the data, and we want to learn the set of instructions. I'm going to skip all of this, a lot of information here. I'm going to skip. Type of learning. So when we are talking about machine learning, there are 4 type of 5 type of learning: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, and active machine learning learning. So of course we are going to talk about 2 types, supervised and unsupervised. So the supervised learning is simply in the data that was in the historical data, we have we know what we are trying to do, and we already know what we are trying to accomplish. Like for example, so this is a historical data for the bank problem that we are trying to find a solution to. We already know that in the historical data, we already know that the clients were either purchased the term deposit or they did not purchase it. We already have that piece of information. It's called target variable. We already have a target variable. Okay, it's called the target variable. We already know something about our clients. We already can classify them as either they did not have a term deposit or they have a term deposit. So when you know something about your when you can when you already learn something about your client or customers or whatever problem you're trying to solve, it's called supervised learning. We already have something to supervise our learning. So anyway, when you have when you know something about your data, it's called supervised learning. In our case, we already have a target variable. So when you have a target variable, it's simply we know we have something to supervise our learning. Sometimes you don't have this target variable. You know nothing. You know nothing about about your data. That is called unsupervised learning. In supervised learning, we already know something about the problem we're trying to solve, and we are going to build a model to try to find a mathematical relationship between all features and the target variable. So we want to find a mathematical relationship. So this is a y, or a target variable, and this is x1, x2, x3, all the way to xn. So in supervised learning, we are gonna, if you want to predict the y, we need to find the mathematical function of x1 plus x2 plus x3 plus xn. This is why we try in, this is the pattern, that the mathematical patterns we want to learn from this relationship. Once we learn this, if you have any new data, just apply this function to it and you are going to get the y for that data. So that is called supervised learning. Unsupervised learning is no target variable, and of course this type of function is not going to work. So we have only x's, so we don't have x and y, we have only x's in the data, and instead of learning a function, then first thing that we get to learn is learn a structure, the underlying structure of the data. Okay, that is difference between supervised learning, where we have a target variable, and unsupervised learning when we don't have a target variable. Question to you all. So is this a supervised learning problem or unsupervised learning problem? Why and why not?
Supervised, because we do have y value there.
Good. And so yes, that's true. So it's supervised because we have a target variable y. And what type of target variable? What is the type of target variable that we have?
Binary.
So the target variable could be binary. It could be yes, no, no. It could be nominal. It could be yes, no, maybe. That is multi-class. It could be a value like, let's say, house price, 50,000, 250, 350. It could be continuous. And there are so many type of the target variable. Depends on the type of the target variable. The type of the target variable will determine the category of supervised learning. In supervised learning, there are two categories. There are classification. When you are trying to classify a client as either a 0 or a 1, as either bad or good, as either will purchase the term deposit or will not purchase the term deposit, as either they will come back or they won't come back, as either this patient will show up on their next appointment, they wouldn't show up. That is called classification. So we are trying to classify our data set as either A or B. Either A or B. Sometimes A or B or C if it's multi-class. Or it could be a regression if the target variable is not binary, is not nominal, is not multi-class, it's a continuous, is a value. So we got classification if it's A or B, and we got continuous regression if it's a value. So if you were to determine a value of a house, so you are not going to use classification, you are going to use regression. If you're trying to determine if a client will show up or won't show up, A or B. Show up is A, won't show up is B. Either class A or class B, that is called classification. So supervised learning is two part. So classification and regression, and looking into this data here, what do you think will be the learning category? So we already know it's supervised learning.
Classification.
Because we have a target variable, and we are going to do classification because it's we are going to do classification because we have a binary target variable. Okay, and in the real life, in real life, we make decisions. We make a lot of decisions. Think about it. How many decisions that you made this morning before you joined the class? You made a decision on what to eat, when to wake up, whom to call in the morning. You made it. Even though some of the decisions that we make, unplanned decisions. So the moment you wake up, you look into the phone to see if there is any news out there. So tell me how many, what are some of the methods that we use to make a decision? As a human, how do we make decisions? Let's say that you want to study a master's degree, a master's in data science, and you have Georgia Tech in Atlanta, and you have Nashville, let's say Tennessee University. How do you make a decision to which college to go to?
Based on your skill set.
In other words, it's based on some information, right?
Yeah, it includes multiple things, like maybe I prefer some location, maybe some quality education there, maybe something like a lot of factors will involve to decide which institute I need to go.
It's all about information.
Yeah.
Information. So if your friend of yours, if you have two friends, one went to Tennessee University, one or Georgia Tech, they spent $10,000 each, and then the person, your friend who joined Tennessee, got a job right after she completed the program, and the guy who is taking Georgia Tech, they are still in the market. Of course, I'm going to go to and the person, they are very smart, hardworking, and of course, I'm not going to go to Georgia Tech. So we make decisions based on information, available information. What else? What else do we need to make as a human? What else do we need to make a better decision?
Finance.
Say again?
Finance.
So
like whether you are getting a scholarship or you have to pay the whole college fee from your side. I mean, that kind of financial implication.
Yes, that's true. But what are you doing here? What are you doing?
Yeah, again, the information you gather the information.
No, it's more than information.
Analytics.
Comparing. Yes, it's comparison. Comparing.
Yes.
Yeah, comparing the program with scholarship, program without scholarship, And based on what comparison, of course, you are going to make a decision either to go or not to go. And if you can afford it, then you go for it. If you cannot afford it, then of course you are not going to go through it. Number 3, there is a lot of ways to make a decision in our life. Number 3, let's say that you and the family, you've been planning for an outside trip, like tomorrow is Sunday, beautiful day, and you're planning for a trip outside. What is how do you make the decision? What if it's raining? Are you still gonna go? What if the weather is gonna be very, very bad? Are you still gonna go for a picnic? So we are making decisions using some probabilities. Of course, if we are ready for a picnic, we've been planning for it, but if there is a probability that it's going to rain tomorrow, I'm going to cancel. Okay? So the fourth one, what is there are a lot of methods to make that we use to make a decision. The fourth one is an error. So you went to New York in summer, or you went to a restaurant A, and you paid $100, and the food is horrible. The next day, your wife, your daughter asks you for a restaurant. Do you think you are going to take her to the same restaurant? Yes or no?
No.
No.
Why?
Experience?
Experience or error? Because we made an error, we learned from it. I am not going to make that error again. So in the theory, we need to build machine learning who can mimic the human behavior. It's going to mimic the way we human make decisions. So we want to build a machine learning that can learn from the data using the information of the data, using the patterns. We can build a machine learning that takes the patterns of the data and compare them and make a decision. We can use machine learning that calculates the probabilities of within your data. We can build machine learning that can learn by simply making errors. So it's we have machine learning, we have information-based learning, machine learning. And good example is a good example of a model of an algorithm that is using the information-based learning method is decision tree, random forest, and any models that use decision tree as base learner, like bagging and boosting. Then we got similarities and comparison. Your friend married a Moroccan sister. They are, he's very happy, and of course, you are going to try to marry a Moroccan sister, but don't. So you are, you're comparing, something. You're comparing two things, and find the similarities, and based on what you found, of course, you are going to make a decision. So in the machine learning, we have this concept, similarities-based learning using the Euclideans or KNN. KNN is a good example of model that use similarities. Clustering analysis, k-nearest neighbor, and we got here k-means clustering. And of course, some models, they use the probability. So they learn, you feed the data, and then you apply some probability learning in there. And logistic regression is naive based. They all use the probability to learn, and some of them, they are using error based. So they learn, they make an error, then they try to fix it and learn from the error. And support vector machine is a model that learns from the error base. So we're trying to build a machine learning that mimics the way human make decisions in our daily life, that we make decisions. So these are some of the methods we are making decisions every day. Either you know it or you don't know it. Either you have the intention to make a decision or you don't. I mean, all the decisions we are making, we are either making decision because we have some information, because we are comparing things, because we have some values, some numbers to make to help us make a better decision, or because we already have experience in that area. We already made a lot of problems, a lot of mistakes, a lot of errors, and of course we are not gonna repeat those mistakes. So the first model we are going to learn is a model that uses information-based learning. And that is what we are going to cover tomorrow, inshallah. So any question, concern about machine learning in general, or the way a human makes decisions, and the models that we are going to learn to mimic the way we make decisions. At the end of the day, you will, they hired us data scientists to help management make a better decisions for their businesses, for their industries, using the data. And you could learn from the data using information, similarities, probabilities, error based. So any questions, concerns about this?
So, Mo, one question: are there any mathematical model available, like in Python or other languages, which industries are using directly, or everyone they are basically developing their own
No, these
mathematical
are
model?
all been developed. It's been
Okay.
research, it's transferred from the academia into industry. Of course, in the industry, we got the libraries. In the academia,
Okay.
it's all math, all research and things. Yeah, it's one model. Decision tree is already a library that we are
Okay.
going to use, but we need to understand how this decision tree works, the underlying structure of the decision tree.
Okay. Okay. Okay.
Okay, so tomorrow we are gonna learn one model that uses information based, and we are gonna implement that model on the data set that we have. So we are going to implement it on this data set. So tomorrow we are going to learn decision tree, the foundation, the basic things about decision tree, how decision tree learns from the data, and of course we are going to implement that decision tree on this data. Okay, that is the plan for tomorrow. So any question, any concern, any doubt? Going once, going twice. Thank you guys for the business. And as I said, if you are interested in the program, go ahead and register to reserve your spot. And I'll talk to you tomorrow. Until then, you guys have a good evening, and bye, everybody.
Thank you. Thank you, brother. Thank you.